Electron beam melting, metal 3D printing, powder bed fusion using an electron beam. I'm Pete Zielinski with Additive Manufacturing Media.
And I'm Stephanie Hendrickson. In this video, we'll break down electron beam melting, or EBM, talk about what it is, how it works, the advantages of this process, and its possible applications. So let's get started. Pete, what is EBM?
It is a metal additive manufacturing process. So the starting point is a bed of powder metal. That powder metal is fused together layer by layer to build the solid metal part. It's an electron beam doing that fusing. Compared to more common laser powder bed fusion, this is a higher energy process. The electron beam is a higher energy source. Can you tell us more about how it works?
Electron beam melting typically takes place inside a machine under vacuum at very high temperatures. So you start by spreading a layer of metal powder across your build area, you preheat all of that powder, and then you use the electron beam to fuse it together, melt it together just in the places where you need to build up your part. You repeat that process over and over and eventually end up with something like a semi-solid block or cake of powder that has all of that preheated powder, regardless of whether or not it was melted, with your solid parts inside. So you need to break your parts out, depowder them, and then continue on with the rest of the workflow. So let's talk about the advantages of this process.
There are several. The higher energy source makes it possible to use larger diameter metal powder. That heavier powder metal is easier to work with, safer to work with. It doesn't pose, for example, the same respiratory risk as fine metal powder. With electron beam melting, it's possible to work with the powder, be around the powder, without necessarily need special safety equipment.
Electron beam melting takes place at higher temperatures than laser powder bed fusion, which means you have better management over the thermal stresses. That means less warping, less distortion, better dimensional accuracy, and it also means that post-processing steps like hot isostatic pressing or hipping probably aren't going to be necessary.
It is a more stable build. The control over thermal stresses means that it's not necessary to rely on support structures to anchor the part in place against deformation. The supports are there instead just to pin the parts in location for the duration of the build. Support structures can be thinner and easier to remove.
Compared to laser powder bed fusion, EBM is typically more productive for a couple of reasons. One, the build rate is just faster, and two, the ability to stack parts and nest them inside the build chamber allows you to produce more parts per print.
Those are advantages of electron beam melting. Now, here are some things that are worth knowing. One is that preheating of all of the build layers produces a finished build that is very hot. It needs to cool down. Cooling is part of the process. It takes place inside the machine. It can take a few hours.
Powder removal can be a challenge. EBM allows for lots of geometric intricacy, and you're also using a larger powder particle size, which can add up to parts with powder trapped inside that can be difficult to get out. So you might need additional post-processing steps, things like ultrasonic powder removal. You might need to add extra inspection into your process just to be absolutely sure there's no unmelted powder inside.
Compared to other powder bed fusion, electron beam melting produces a coarser surface. Laser powder bed fusion has an advantage when it comes to very fine precision work, but both of these processes produce parts that are very close to net shape. So, what is EBM used for?
We've seen electron beam melting used in all kinds of industries, everything from aerospace and energy to medical devices. We've seen it build turbine blades, satellite brackets, medical implants, even parts for the Perseverance Mars rover. Keep in mind that surface finish might be a little bit rougher than what you might get from other processes, but there are actually cases where you might want that, applications where that makes sense. Electron beam melting is very commonly used to make medical implants like hip cups, where an engineered rough surface is actually beneficial to the patient's healing.
Commonalities we've seen in successes with electron beam melting include hard metals, unusual metals, and parts that are kind of large but also feature thin sections or delicate sections where that control over the deformation of the part is very important.
If you want to learn more about electron beam melting or see any of these applications, we'll drop links in the video description below. You can also go to additivemanufacturing.media for lots more on industrial 3D printing. Thanks for watching.